Hello, we are the Smart Grass Mower Group. My name is Liao. This is Ben Potts. She is Emily Bonnette, and she is Natalie Paul.
So our team set out to solve the chore that is mowing your lawn, and the way we decided to do this was to make a robotic lawnmower prototype that focuses on using GPS so you can just let it go in your yard without having to watch over your mower.
For the hardware of the robot, the brains of the operation, we used a Raspberry Pi, which is used to communicate out to the web application that we designed, and it's also used to talk to the Arduino, which controls the motors and the turning and driving of the robot. Also talking to the Raspberry Pi, we have a servo and a LiDAR. And if you don't know what a LiDAR is, it's essentially sends out light and receives back and is then able to tell, based on how long that took, how far away something is. And the servo turns with the LiDAR, so then you're able to have obstacle detection and tell how far away things are based on that. Then also connected, we have our camera, which is used for live streaming, which is a part of the web application that we created. And then also we have a GPS back here, which is used for boundaries of the robot, so it knows where to drive in, and also location of the robot. And then for the Arduino, we have connected a battery, which powers the whole robot. We also have a kill switch and bump switches to make it stop once it hits something, and to be able to kill it on command if it's driving where it shouldn't. And then we also have the motor controller again, and the compass as well, which is controlling the turning of the robot.
So for obstacle avoidance, we basically divide the yard up into a grid, as you can see here. Whenever the LiDAR sensor detects an obstacle, we insert that into the grid. Then we score each grid square based off of if it's been mown or not and how close it is to other unmowed squares. That way it allows us to take a fairly straight path through the lawn like you'd want your lawnmower to do, but also to avoid obstacles in an efficient manner.
For the user interface, we used a web application because it was easier to be used on iOS devices and Android devices. We used Vue.js and Vuetify.js frameworks for building the user interface and for building components and styling. For our web application, the first page is the home page, but we'll have the upcoming mows. Next, we have the scheduler page, which allows you to add mows and repeat weekly. You're allowed to delete them and edit them as well. And then next we have the emergency stop for the user, which will stop the mower. And with that, you can just check to make sure the mower's all right, or if you just wanted to make the mower stop. And once you hit cancel, that will stop the emergency stop and let the mower keep on mowing.
So then two other pages on our web application is the video page. This has a live stream that we talked about earlier from the mower, so you can see what your mower is seeing at all times. And you can also take control of your mower from this page if you want to manually turn it, move it forward, back and forth, stop. And then the last page is called the Locator page. We integrated it with Google Maps. It geolocates to your position when you get there, and then you can draw on the map the borders that you want your lawnmower to stay within. And then that will make sure that with the Raspberry Pi and the application that your lawnmower stays within your yard. Overall, our team built the web application that can control our lawnmower autonomously in the backyard. So it has its obstacle detection, and it's used by GPS to stay within the yard. And overall, it makes it easier for people to get their lawn mowed and keep it looking nice throughout the year.